Well, welcome to our video here on Venn diagrams. You might remember that we had some categorical propositions. Those are A, E, I, O. And those are both the universal propositions and the particular. So let's go ahead and just start with the universal affirmative. All S is P. And how do we diagram that? By the way, this is an A proposition. So we first start out by drawing a circle here, and then we draw a circle here, and then we label S and P. Now, all S's are P means that you remove all the S's in the universe by effectively deleting them or pushing them all, as I will show you a little bit later when I talk about distribution. You push them all to the P category. So one way to think about this is like, all the S's just get pushed into the P category, right, or the P class. That's just one way to think about it, and that arrow might be confusing, but the way I kind of intuitively think about it is like this. I draw the circle here, and I draw the circle here, and then I just push it all over with the arrows, right? And you get this same kind of drawing, but it just kind of unlocks my own intuitions about, what's going on here. And pushing is just a notion that, it really has nothing to do with pushing. I'm just, you push all the S's into the P category, and all those are the only S's that exist in the universe. So let's go to the next one. So this is going to be no S is P. So this is an E proposition. So again, we just draw our two circles here, and then we label S and P. And then what we're going to do here is we're going to, we're going to get rid of this intersection, right? Because no S's or P's. So if we delete the intersection, then there's nothing in the universe that is both an S and a P. The way I kind of think about this is a double arrow, and I think about it as being pushed apart. So, don't take too much, don't buy too much into these arrows. They only mean, S is being pushed apart from P, or all the S's are being pushed into the P category over here. So don't pay any mind don't buy too much into the arrow itself. It's just an arrow, and it doesn't have real meaning. It's just the way I intuitively try to diagram. So if I were going to diagram this using those arrows, I would just draw them like this. And what that's supposed to do is, when you think about two circles being pushed apart, you just think of them like this, right? So once they're pushed apart, no S is a P because they don't intersect. Same here. If you think about this redrawing of the picture, it would be like this, right? So these would be all your S's that are also P's. So these are S and P's. So this is the part of the universe where all the S and P's live. And you don't have to think about it this way. The only reason I do it is because it's efficient to think about distribution in these terms at the same time as learning how to diagram them. So let's go to a particular. We'll do the affirmative particular first. So sum S is P, and we just we want to draw a couple circles here and label them, and we just draw an X in the middle. And you might be wondering, how I intuitively think about this. Well, I just think about, one thing in the middle of the S and the P's, and that's it. There's no real arrows because you're not really doing anything. You're just talking about, one X, right? And that's just in the middle of both categories. So there's that's how you diagram it. You can think about some of our immediate inferences from a little while ago, and you can say, oh, well, this is why sum p is an S. Oh, wow. Yeah, I mean, that's because, you're not doing anything. So it just so happens to be the case that, sum p is S and sum S is P. And that's, the picture shows you why the immediate inference actually follows. So let's go to the negative particular case. So sum S is not P. And I just want to underline this word "not" for a second before I draw this. So you want to draw these circles out here. You want to label them S and P, and then you draw an X here, right? And if you just read the sentence, sum S is not P, right? It's not in P. This is I draw two arrows to think about this, and I kind of draw them like this, right? I draw the X and then I draw them kind of like this, right? And the reason I do that is because when you look at it in terms of two circles, S and P, this X is excluded from this entire category, right? So it's actually, this proposition is talking about it's excluding the entire category of P. I know that's a little bit abstract, but that's definitely the case. And this is how you diagram all these pictures. So I'm just going to try to separate here. Let's find a different color to draw a separating line. So I'm going to use red. I'm going to just separate here how you diagram each proposition. And that's how you diagram each proposition. Everything above or in the red box is how you do it. And then kind of how I've drawn these pictures here. Let's find another color. Let's go with yellow. So everything in the yellow column here, this actually conveys something a little different. Everything like in the yellow area, it actually conveys distribution and how the propositions distribute. I know this is a little bit simple and it is in fact naive, but if you just kind of look at this overall grid, what you'll see is that when you just start thinking about your table again, let's see if I can find a place to draw it. Hold on here. If you just start thinking about your distribution table, you might realize that it looks very familiar to you. And I'm just going to find a little place over here in the corner to draw it. Let's see here. Let me go back to my normal. Let's do another color. Let's see how this looks here. So if you think about your table, A, E, I, and O, right? And then you just draw a little grid here with S and P, right? And whether or not these distribute. The S, it distributes, right? And this is kind of obvious by this picture over here. Bling. The E, both propositions distribute, right? So they're both being pushed apart, and this is just pa-ching, pa-ching. And then you look at I, and you say, nothing's distributing because nothing's moving around these two circles, So this also corresponds with the table, but it does not distribute. Neither S nor P distribute in the I. When you look at the O, yeah, this distributes because it's excluding the entire category. This is the distribution table that we learned in the book, and this is how you can think about it in terms of how we actually diagram these propositions. So I will start with another video, and I will see you soon.